Okay, sorry for the delay here. But we're on question number 4 now. Listen, I ask you to try to make an observation about how you know which one is the smallest and how do you know which one is the largest. So please, again, this is important information, and I'm only trying to help you understand numbers better. All right? So I want you to tell me this. If I said 1/3. Would everybody agree that that's kind of the same as the other fractions, right? Not equal, but just the same pattern, correct? And then if I said 2/4, you would agree with that, right? And then if I said 3/5, do you agree that's pretty much the same? Right? Because there's 2 in between the numerator and denominator. Does everybody agree? Now, what was the fraction 1/3? What was the fraction as a decimal? Go ahead, tell me. Point, yes, you're right. Good job, buddy. Point 3 repeated. What's 2/4 the same as?
Point
Very nice work. And what's 3/5 the same as? 0.6. Good job. Now listen, all I'm asking you to do is kind of think with me right now. That's all I'm asking you to do. I'm showing you how you should be thinking about this. Now, what do you notice about 1/3, 2/4, and 3/5? What do you notice about those decimals? No, look right here though. In other words, what's going on right here? What are the decimals doing? Like if I ask you next, what's 4/6? 4/6 would be 0.6 repeated. Everybody with me on that? So what I'm asking someone to tell me, what does it appear that the decimals are doing? Are they staying the same? No. Are they getting smaller?
No.
Are they increasing?
Yes.
Yeah, does everybody see they're increasing, right? So what can we conclude about this? No, don't be sorry. Don't be sorry. I don't want you to say that anymore. All right, because you're a good thinker. All right? Here we go. Look right here. I'm trying to ask you about those fractions. Your job is to make a conclusion about what's going on with the fractions as I increase 28/30, 29/31, 30/32. Are those written in the right order is what I'm trying to say.
Yes.
Yes. How do we know that? Well, we didn't at first, but we drew a conclusion based off of what? Based off of these numbers right here, right? We used something that we knew is true, right? We know 1/3, 2/4, 3/5, 4/6 is increasing. You agree?
Oh, yeah.
Now, the pattern in math isn't going to change. So what are we saying? This right here has to be increasing. So the smallest fraction is what? 20/30. And then what? 20/31. And then 30/32. Do you agree? Do you want to divide it to see that I'm correct, or are you going to believe me? You should believe me. That's a good answer. Because now I don't have to do what? I don't have to do all those division problems. All right? I know you can do the division. This was very hard. All right? Understanding what I just said about the order, 28/30, 29/31, and 30/32. What was the number what? Oh, 6 repeating? Is that what you're asking me about? I'm sorry, I didn't write that clear. This right here, right? This is 6 repeated, sorry. All right? So, who asked me about number 4 again? You good with that explanation now? All right. Again, that's just a nice little question. All right. Most kids don't know, or they wouldn't know that that is increasing. All right. If we put the numbers 28/30, 29/31, and 30/32. All right. Now, does anybody else have any other questions about last night's homework? All right. What I'm going to do the last 5 or 6 minutes of class, I'm going to call you up to my desk and take a look at it. Yes.
The number 5.
Listen, I want you to sit up. Yeah, come on, talk to me.
Number 5.
Is it the word problem or so on this page? So what do you ask me about 3/40? Is that what you're asking me about? All right, so you could just divide that out, right? But now, do you remember when I said you could make it out of 1,000, right? Let me show you something I would do if I were doing this problem. All right, what I would do is watch. To make you smart, I would multiply by 5 over 5, and that would be 15 over 200. Does everybody agree with that? Right. Now I'm almost at what? I'm almost at 1,000, right? So I can multiply that again by what? 5 over 5. Do you agree with that? And then that would be 75 over 1,000. Everybody agreeing with me? And now the hard part. What decimal is 75 over 1,000? Be smart. So we're 0.750. Yeah, listen to what she's saying, right? 75 thousandths, right? So you would think it would be 0.750, right? But in fact, it's 0.075. All right, remember a long time ago you learned that the decimal ends in the place that it was. In other words, you said that was 75 over 1,000, so 5 has to end in 1,000 spot. All right, I think that's a good question. Again, I'm trying to make it so you don't have to do the division. All right, you're trying to figure out ways that you can avoid the division. Yes.
Number 6.
8/11ths.
Oh no,
Okay.
number 6.
Listen, I need you to sit up for me. But because I said, does anybody else have any other questions with the word problems? All right. You got it, Sebastian. Come on now. You're super smart. You got to stay with me. All right.
So on number 6, I did I rounded to the nearest multiple.
Okay, let me read it real quick. It says Angie can paint one room with 2/3 of a canister of one shade of green paint. She will need 5/8 of a canister of the same shade of green paint for a second room. Does Angie have enough of this shade of green paint to finish a second room? You think so? Well, why do you think no? Because 2/3 is what decimal? Very nice. 0.6 repeated. What's 5/8? Go ahead, tell him. Beautiful. 0.625. So basically what that's saying is if you use 0.6 of the can, do you have enough to do the other room? No, because these two together make more than one. You understand that? Right? It would have to be like 0.5 and 0.5. Or 0.4 and 0.5. Then you'd have enough. Does that agree? Do you agree with me? All right. All right. Let's go ahead and get started on today's assignment, guys. All right, that was good. All right. Now, today's assignment is 3.2 worksheet, right? What?
I have a question.
What? What do you want about -2 or 3? No, I'm saying, what is the question? Like, you should know what 2/3 is now, right? What's the decimal 2/3? 0.6 repeated. You should know that. Those are the things and so then it would just be -0.6 repeated. All right, come on. All right, now I want to get to this because I want to have some time to play from the desk and take a look at your work from last night. All right, now what we're doing is we're converting decimals now to what? Fractions. Yesterday we did fractions to decimals. Now we're going what? Yeah, decimals to fractions. It's very easy. All right, I'm expecting everybody in here to go, wow, this is really something. All right. Now, write each number as a fraction. So how do I write 13 as a fraction? Everybody should be able to just tell me quickly that's 13 over. Whoa, 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 whoa. 13 over
100.
13 over 100 is the same as 13.
13 over 1.
Thank you. 13 over 1. Somebody reasonable back in the back, right? 13 over 1. Wow, you guys killed me on that one. All right. This is, see if you can redeem yourself. Number 4. Negative 25, Colin, is what fraction?
25 over negative 1.
All right, you could say that, yes. But I would prefer you just say negative 25 over 1.
Yeah.
Either way. All right, any whole number you can just put over what?
1.
Over 1. Wow. So, negative 1, Vivian, is what? We are amazing. Negative 1 over 1. All right, now let's look at question number 2. Question number 2, that's called a mixed fraction. We have to convert it to an okay, do you remember how to do that? What is it? You are amazing. 5 over 4. Beautiful work. 5 over 4. Uh-oh. 3 4/5.
Oh. Okay.
Yes, you.
Okay.
What do I do?
You have to, like, I think, like, go, like, 5 times 3
Yes?
plus 4 is 19 over 5.
Yes.
I mean, negative 19.
You are awesome, buddy. Negative 19 over 5. All right, who's got volunteering for number 8? Good, Julian.
It would be 20 over 9.
There you go. That's better, Julian, okay? Follow along with me. All right, number 3, that's no big deal for us. That's just what? 57 over 1. And how about number 6, Abby? 53 over what?
8.
You're awesome. Very good. And of course, we don't have to think about number 9 anymore. That's just what? 12 over 1. All right. Now, for those of you guys who paid attention yesterday, and for those of you guys who have what I asked you to try to put into your brain, this now over here is going to be really easy for us. All right. But if you didn't remember the information I told you yesterday, then this is going to be a little bit what? A little bit harder. All right. So let's start with point 6. Let's start with point 6. Now, that's 6 repeated. So now let's say you forgot. So you can always put 0.6 over what? 6 over, leave her alone. I'm trying to help everybody.
Wait, 6 over 1?
Yeah, well, but now it's 0.6 though.
Oh, so
6 over what? Come on now. Now, if you read that decimal, it's read as 6/10. And sometimes kids don't make the connection. That literally means 6/10, which is the fraction what? 6/10. Right? And then you just reduce it. So 6/10 reduces to what? Let her answer. 6/10. Do you remember?
Oh, yeah. So 3
Over.
5.
Beautiful. All right, we're just going to go around the room. Number 11.
11, 25 over 100.
Yes, 1/4. Beautiful. Uh-oh. You remember this? You're up. Yes, everybody should be able to just tell me that's 4 over 9. Beautiful work. All right. Next one. Julia. 13.
13.
No, no, no. Now listen, let's do this first. Here's what I want you to remember now. The number -1 is just -1, right? So we'll write -1 down. Now come on, what's 1 repeated? Yeah, what number? Something over 9. What is it? Yes, that's right, 1/9. All right. Now, as we get more advanced, we don't really write as mixed fractions anymore. I want to convert this to improper. So what would that be? No, 13. So right now it's negative 1 1/9, but we got to do it over negative 10 over. Yeah, remember the fraction stays the same. Good? All right, stay with me now. Avery, oh, you got a good one? Point 11 is what? No, you don't, it's not something you memorize. It's just, remember that says 11/100ths. That's all there is. Remember, if there's 2 decimal places, it requires over 100. 11 over 100. All right, Ellis, you tell me about 15. What would that be? Yes, now listen, we're going to save some time now. Does everybody listen to me now? Watch. Instead of saying this, and you are correct, by the way, so I don't want you to think I'm correcting you. That could be that. But I also remember we want improper fractions, so it would just be easier to say it's just to start out as 28 over 10. Does that make sense? All right, now you got to reduce that for me. So what is 28/10 reduced to? You're awesome, girl. 14 over 5. Very good. All right, Julian, 16. This Julian. Now, you're trying to apply. Listen to me now. I'm trying to make you, again, better with numbers. So, Julian, you have to really make a connection now with what I did to 15. You see what I did with 15? I made it 28 over 10. So, the quickest way to do that is to make it what?
It's just to skip the
So, just tell me the answer. Look at 15. So 2 8/10 is 28 over 10. So this would be 700 and
703
over
0 or over 10 or
100.
Oh yeah, because it's the double
Yeah, it's called the hundredth spot. Tenths, hundredths. 73 over 100. Is everybody okay with that explanation? Or that's just the quickest way. I don't feel like doing 7 and 3 over 100 and multiply and add. Bless you. All right, here we go. 17. Ooh, you got a good one. Now this one is a little bit different. It's a little different rule because of the fraction bar. So I want you to write this one as 2 and what?
2 and 12.
12 over. You said it like 5 times at the beginning of class.
Oh.
12 over what? No.
10.
Tell him.
9.
Close.
10.
12 over, girls. Come on, help the boys out.
11.
2 and 12 over what? What in the world are we talking about? Colin, are you helping them out? 12 over what? No!
1.
No. Oh, you guys are killing me. Girls, help the boys. Over what? I told you when something is repeated, over.
9.
Say it.
99.
Yes.
Oh.
Oh, yeah. Nice. Smooth move, guys. Smooth move. So it's 12 over 99. 12 over 99. Now can I reduce 12 and 99?
Yes.
By what? 3. Thank you. So this now is 2 and what? 4 over 33. I'm happy. But we're still not as an improper.
So it's 7.
So it's 70 over 33. Come on now. Everybody knew 20 or 2 times 33 was 66. 66 plus 4. 70 over 33. So listen to what I'm trying to tell you. That's actually pretty cool. Listen to me. If you could tell somebody 2 and 12 repeated is the same as 70 over 33, they'd look at you a little weird. Do you agree, though? That's not really that hard, though, right? It's really not hard. All right, it's understanding the patterns. The math patterns don't change. All right? So here we go. Uh-oh. If you miss this one, you're in bad shape. We're up to Max.
3.
And
2. 20. 2 over 9.
Wow, I was about to come back there and
Nice.
thank you. So 3 and 2 ninths. Now I got to convert that, Max, to what?
Um. Uh. 27.
Close. Come on. 3 times 9 is 27.
29 over 9.
Yeah, come on, come on, come on. I want you to sit up now. Everybody's got to sit up. All right, come on, guys. You can't be sloppy on me now. I'm asking what 3 times 9 plus 2 is, and you're giving me garbage. All right, no more garbage. Okay, let's see. Tell me.
Yes.
What is 0.1?
And 1/8.
You are awesome, buddy. So, yeah, he remembered 0.125 was 1/8. So now write it as an improper fraction, please.
9 over 8.
You're awesome, man. That was a really good job. I'm really proud of you. If you remember those eighths, it's so helpful. All right. Now, number 20. I want you to do it like I asked you to do question number 16. Reese, do you remember what that is? How would I do 20? Give me a hint. It's 865. Over what? Yes.
100.
Yes. Come on, everybody needs to see that, right? Make yourself a note if you didn't see that now. It's 865 over 100. The annoying thing is, though, you have to divide by what? Reduce it by what number? 5. Right? So now we're going to practice reducing by 5. So listen to me out. Hear me, please. All right? I want everybody to be able to divide by 5 mentally. So here we go. 5 goes into 8 how many times? 1. Then you sneak a 3 in the top corner so you can see. So 5 goes into 36 how many times? 5 goes 7 times. How many left over? 1. So I put a 1 in the corner. 5 goes into 15? 3 times. 5 goes into 10?
Twice.
Oh, wait a minute. So that would be a 2 with a 0, 20. Thank you. All right, is everybody pretty happy with that? So 8.65 is the same as 173 over 20. I'm totally good with that. 21. Uh-oh. 21, where am I at? Here, yes. Do you remember? Look at it. What would that be? Yes. So you could write 16 and 7 over 10. Over 10. Now, do you see what I'm trying to show you? Look real carefully. See how I could have just said 167 over 10? Okay, and again, all I'm trying to do is just make you a little bit quicker with the math. All right, Colin, you're up. Uh-oh. Uh-oh. Colin, what are you thinking here? Yes. Come on.
16 over 99.
Yeah, all right. 16 over 99. Amazing. Amazing. Pat yourself on the back. Feels good to be brilliant, doesn't it? All right, here we go. 23. Vivian. You're awesome, girl. 406 over 100, but we can reduce by? Yes, ma'am. And tell me what that is. Shh. No. 2 goes into 4. How many times? Come on. 2 what? Then over. Yeah, awesome. Good job. 203 over 50. All right, Julian, let's see if you got something there. What is that? Shh.
Oh, 5.8 over 10.
What?
No, what?
What?
15 over 99.
Oh, no, listen, that's not bad, actually. That's not bad. So I'm not even upset on that. What I want you to do is the 8 repeating, listen, kind of messes things up. So I don't like doing the 58. All right. What I prefer that you do is I just want you to say -5, and 8 repeating is what again? Shh.
Uh,
What fraction is 8 repeating? Oh, come on. Oh, come on. No. 8 over 9. Thank you. 8 over 9. You with me on that? So remember, guys, I'm trying to tell you, make yourself notes if you want to be smart now. The patterns. Anytime something repeated, it's going to be over 9. All right? If there's 2 digits, it's going to be over 99. All right? So now, convert that over for me real quick as an improper. Shh. I'm waiting. 9 times 5 plus 8. Good. 53, right? Over what? Yes, nice work. Yes, negative 53 over 9. Negative 53 over 9. Put the chairs down, please. Sit the chairs properly. All right. Now, let's continue on. 85 hundredths. How do I write 85 hundredths, Sebastian? Come on, come on.
0.85.
I want it as a fraction.
Oh, 85 over 100.
Yes, 85 over 100, then reduced by a factor of 5. You should know that's 17 over 20. All right, you should know that's 17 over 20. All right. Write 9 and 250 thousandths, all right, as a mixed number. Tell me, Connor.
It is 37.
Number 26. How do I write 9 and 250 thousandths? Yes, that's what I wanted to hear out of anybody. 9 and 250 over 1,000. But 250 over 1,000 reduces to what? Yes, good job, buddy. 9 and 1/4. That's what I want out of you guys. 9 and 1/4. Pay attention now. 9 and 1/4. All right. Now, identify all the sets to which each number belongs. 16. Do you remember? That was a what type of number?
Natural.
Natural number. What else is it? A whole number. It is also an integer. Do we talk about integers? And it's also a rational number. All right, so a natural number, let's just review. Natural number starts with the number what? 1, 2, 3, ... Whole number starts with what? 0, 1, 2, ... Integers, remember, ... it was -2, -1. They're the positives and the negatives. We did this, guys. Right? And the rational number is any number that can be written as a...
Rational.
Yes, any number that can be written as a fraction. Any number that can be written as a fraction. All right, so what would irrational mean?
Not
Right, cannot be written as a fraction. Okay, that's what that means. All right. So now, is, for number 28, is -2.54 a natural number? No. Is it a whole number? Is it an integer? Is it rational? Yes, because it's a terminating decimal. If the decimal stops, it can be written as a rational. All right? So all I just need you to do is put rational down there. All right. 9/3. All right, what is 9 divided by 3? That's 3. So then that is, but let's start at the beginning. Is it a natural?
Yes.
Yes, natural. Is it a whole number?
Yes.
Yes. Is it an integer?
Yes.
Is it rational?
Yes.
All right, there you go, guys. Natural, whole, integer, and rational. All right, 0.95 repeating. Can that be written as a fraction?
Yes.
So it is rational. Any number that repeats can be written as a fraction. So that's rational. All right. What about -4? Is that a natural number?
No, it's integer.
No. Is it a whole number?
Yes.
Whole number?
No.
No.
Integer.
No, whole number starts with 0. There's no negatives. So the first one it belongs to is a what?
Integer.
It's an integer. And is it rational?
No.
Can you make it a fraction? Come on, come on. 4 is the same as 4 over 1. It can be written as a fraction. All right? Now, 32, does this decimal end? Does it repeat? No. And what I mean by repeat is if it's like 1, 2, 1, 2, 1, 2, or 1, 2, 3, 1, 2, 3, 1, 2, 3. Does that have a repeated number? No. All right, it doesn't have. Although you're adding a 0 in between 2's, that's not a repeated number. Is everybody with me on that? All right, so this is just called what? Irrational. If the pattern doesn't repeat, it's automatically irrational. All right, it's automatically irrational. All right, now I'm trying to think about this. All right, so here's what I need for you to do, guys. Again, I want everybody to put this up on the top of this page. Odds,
Yes, thank you.
right? All you have to do is the odds on that page, and then the word problems are super important. So 1 through 6. Is everybody hearing me? Odds and 1 through 6. Odds and 1 through 6.
I have a question. What is the full page on this section?
This you have to do the odds on the second worksheet, right? And all of 1 through 6 on the third.
Okay.
32. The answer was it's irrational. Okay, it's irrational. What?
What is the test?
I'm not worried about that. I think it's next Friday.